So in this video today, we're going to talk about the application of trig ratios. So every problem we're going to do today is a right triangle. Okay, so we're going to draw that, and we're going to use Pythagorean's theorem for these problems, or sine, cosine, or tangent. Okay. So in example 1, it says shipmate set a boat to sail exactly 27 degrees northeast from the dock. Okay, so if we got the dock over here, okay, and it says 27, okay, so y'all know northeast, north is here, east is there, right? So that means if we start here and we go up there like that, right? And then it says, after traveling 120 miles, the shipmate realized that he misunderstood the directions from the captain. He was supposed to set sail and go directly east, okay? So right now, it says he went 120 miles, right? Okay, and then what was the angle right here? 27 degrees, okay? So I'm going to create a right triangle here. Okay, and it says how many miles will the shipmate have to travel directly south before he is directly east of the dock? Okay, so that means we're talking about this right here, right? That would mean south, because south is down here, yes? Okay. So now what we need to find is x. So what we want to do is we want to look at, we got a right angle right there, right? Okay, so what is the 120? That's going to be our hypotenuse, right? And what is the x? That's going to be our opposite. What ratio uses opposite and hypotenuse? That would be sine. So we're going to do the sine of 27 is equal to x over 120. Remember, if we're trying to get rid of something that's being divided, we multiply, right? So we're going to multiply both sides by our 120 here. So what we're going to put in our calculator is 120 sine of 27, because that canceled out over there. So that's what's going to give us our x. So go ahead and do that in your calculator right now. So x is equal to 54 miles. Okay. So, actually, that was this answer, 54 miles, right? Okay, then it says how many extra miles does the shipmate travel by going the wrong direction compared to going directly east? So if we were going to do that, we would be solving for y, right? So if we're solving for y, and we still got the 27 degrees, then now we have the adjacent. Isn't this the adjacent in the hypotenuse? So once again, we would do the cosine of 27 is equal to y over our 120. So this time we're going to have the 120, again, 120, we're going to multiply it times both sides, cosine of 27, that's going to be equal to my y here. Okay, so when I did that, I got 107 miles. Put that over there. Okay, so now we could have used this a squared plus b squared equals c squared, right? So we could have done the 54 squared plus the y squared is equal to the 120. We could have also done it that way, okay? So then it's asking us how many extra miles does the shipmate travel by going the wrong direction compared to going directly east? So the wrong direction would have been the 120 plus this is our 54, right, y'all? So we're going to do 120 plus the 54. That's going to be 174, and we're going to subtract from it 107. And so 67 miles is how much further they went than they should have. Ooh, that's a lot of gas. All right, so the next one says, Mr. Wandera is flying a kite in the park. The kite string is 65 meters long and forms a 64-degree angle with the ground. How high is the kite from the ground? It says draw a picture. So go ahead and pause here and go ahead and do this and come back to me when you're done. So in this one, I got the ground down here and I got my kite string up there, right? It says the kite string is 65 meters. Okay, and it forms a 64-degree angle with the ground. How high is the kite from the ground? So aren't we looking for that right there? There's our right angle. So what do we have? So we have our hypotenuse right here, right? This is our hypotenuse because opposite the right angle. And then we have, this is opposite. So isn't that going to be sine? It is. So we're going to say the sine of 64 is equal to x over 65. So once again, we're going to multiply both sides by the 65. So it's going to give us 65 sine of 64 is equal to x. So that's going to be 58. How high is the kite from the ground? So we're going to say 58 meters, right? We're just going to round it to a whole meter, okay? All right, so the next one says a 12-foot slide is attached to a swing set. The slide makes a 65-degree angle with the swing set. So a 12-foot slide, so the slide goes that way. This is a 12-foot slide, right? It's attached to a swing set, so there's our swing set. The slide makes a 65-degree angle with the swing set, so it means there's a 65-degree angle up there, right? And then it says, what is the height of the top of the slide? So we're looking for height over there, right? So wouldn't this be the top of the slide right there? Okay, so again, we got a right angle here, so we got a hypotenuse, right? And then we got the side that's adjacent to the 65-degree angle, right? So what ratio is that? You got it, cosine. So the cosine of 65 is equal to x over 12. So once again, we're going to multiply by 12, right? 12 cosine of 65, that's equal to x. To put that directly in your calculator, and when I did that, I got 5.07, so we're going to say 5 feet is what x is equal to, okay? So our next one says a ramp is used to load a four-wheeler onto a truck bed that is 3 feet above ground, okay? So we got a ramp, and it's 3 feet above ground. The angle that the ramp makes with the ground is 32 degrees. Okay. What is the horizontal distance covered by the ramp? Okay, so that means it's asking us to solve for that. So how does the 3 feet relate to the 32? It's opposite, right? How does the x relate to it? It's our adjacent. So what ratio uses adjacent and opposite? That would be tangent. So we're going to do the tangent of 32 is equal to 3 over x. Remember, if there's a variable in the denominator, they're going to swap places. So this is going to be x is equal to 3 divided by the tangent of 32. So 3 divided by the tangent of 32 is 4.8 feet. 4.8 feet. So if we had to round that to a whole round to the nearest 100th, let me see, it was 4.80. Okay. So that would be, because the next decimal is smaller, okay? All right, let's see if you guys can do this. You try, come back to me when you're done. Straight road to the top of a hill is 2,500 feet long, and it makes an angle of 12 degrees with the horizontal. Find the height of the hill. So it's asking us to find that, right? So how does that relate to the x? I mean to the 12. It is opposite, right? And isn't this our hypotenuse? What ratio? It uses h and o. Sine. So we're going to do the sine of 12. That's equal to our x over our 2,500. So we're going to, remember, multiply both sides by 2,500. So this is going to be 2,500 sine of 12 equals x. Put that right in the calculator just like that, and this is 519.78 feet. And it didn't tell me how to round it, so I'm just going to leave it like that, okay? That's equal to my x. All right, so example 3 says a boy flying a kite lets out 300 feet of string, and assuming that the string is straight, and if the kite is 184.7 feet above the ground, what angle does the kite string make with the ground? Round to the nearest degree. Okay, so a boy flying a kite lets out 300 feet of string. So our kite would be up here, right? Right? Okay. If the kite is 184 feet above the ground, so now it's 184.7 feet, what angle does the kite string make with the ground? So we got our right angle right here. So this is what it's asking me to find, right? So how does the 184.7 relate? It's our opposite, right? This is our hypotenuse. So what ratio uses O and H? So this time we're finding an angle, right? So we're going to do the inverse sine. It's sine, okay? So that's going to be to the -1. You put second sine. So this is 184.7 divided by 300. Put that in your calculator and it should tell you the angle. It is 38 degrees, okay? All right, let's see if you guys can do these next two. Come back to me when you're done. This one says if an airplane travels a distance of 2,057.8 feet horizontally, so this would be 2,057.8 feet horizontally ground distance, and has attained an altitude, that's height, right, y'all, of 400 feet. What angle did the ascent make with the ground? So it's asking us for this angle right there, isn't it? Okay, so if we're looking for that angle, this is what? Relative to the angle opposite, right? And this is adjacent, isn't it? What ratio is that? So once again, we're trying to find the angle, so we're going to do the inverse. Okay, so that's going to be 400 divided by 2057.8. And when we put that in the calculator, we get 11 degrees. Round to the nearest degree, it says, okay? Last one, 37.7 foot wire is attached to the top of a pole. So we have a pole, right? And we have a wire attached to it. So that's our pole and that's our wire. So our wire is 37.7 feet, right? And reaches a stake in the ground 20 feet from the foot of the pole. So this is a 20 feet here. So there's our right angle. It says, what angle does the wire make with the ground? So it's asking us to find this, okay? So that's obviously our hypotenuse. And this is going to be adjacent, isn't it? So we're going to do the cosine, the inverse cosine, right? Because we're trying to find an angle. And that's going to be 20 adjacent over hypotenuse, right? 37.7. So we're going to round this to the nearest degree. So this is 58 degrees because it was 57.96. Okay, that's it.